Hello everyone. So this is the next video on atoms, molecules and compounds. In this lesson we will discuss about the chemical bonding and electron valencies. In the previous lecture we have discussed about an atom, structure of an atom, and about proton and electrons. So the proton are positively charged bodies which are present inside the nucleus and they remain stable, and the electrons are negatively charged which are present outside the nucleus and they revolve around the around the nucleus because they are highly unstable. So the electrons in an atom are located at different energy levels. Okay, there are different energy levels outside the nucleus around which these electrons rotate. So as the energy level increases, the instability of an electron also increases. So the chances to participate with another atom also increases because these are highly unstable electrons. So electrons in the highest energy levels are called valence electrons, and the number of valence electrons governs an atom's bonding behavior. Okay, now atoms are much more stable or less reactive with a full valence shell if the outer valence shell is full. There is no need of participation with another atom or reaction because the outer valence shell is complete and the atom is more stable. This stability can be achieved one of two ways, that is, with if the outer shell is not complete, atom tries to uh, make its outer shell complete with one or two ways, that is, by sharing its electrons with another or with giving or accepting an electron. Okay, so there are two ways: ionic bond and covalent bond. By moving electrons, the two atoms become linked. This is known as chemical bonding. Now, what is the maximum number of valence electrons for a full valence shell? The answer is 8. Now, three main types of chemical bonds are ionic, covalent, and hydrogen. Now, we'll discuss separately. Ionic bonds. It involves the transfer of electrons between two atoms. Okay, suppose we have sodium and chlorine. Sodium has one valence electron in its outer shell because its atomic number is 11, and the distribution of electrons will be 2 in the first shell, okay, then 8 in the second, and the remaining 1 will be in the outer shell. So this remaining 1 electron is highly unstable and it will try to stabilize its outer shell by participating in a bond formation. So chlorine is another atom which contains 17 electrons. So if it accepts one electron from sodium, it will complete its outer shell, that is 8 atoms, yeah, sorry, 8 electrons, and sodium will also stabilize because it will give one electron to chlorine, and it will also balance its valency in the outer shell. Okay, now sodium plus chloride will form sodium chloride, and it is a stable compound. That's why there is a definition of ion: an atom or group of atoms which have lost or gained one or more electrons, making them negatively or positively charged, is called ion. Suppose there is a atom, if it gives electrons or it accepts electrons, and after accepting or giving, it becomes charged, that is negatively or positively, it is called an ion. Now, what are the positively charged ions called? These are cations. And what are the negatively charged ions called? These are anions. Okay. Now, Ions are of two types, acids and bases. Now, an acid is any ionic compound that releases hydrogen ions in solution, and base is any ionic compound that releases hydroxyl ion, that is OH minus, in solution. Okay. Now, measurements of acidity and alkalinity. Acidity of a solution is measured by concentration of hydrogen ions, H plus ions. Suppose there is an acid which releases more H plus ions, it will be more acidic. Therefore, the pH means basically it is called power of hydrogen, means more hydrogen ion concentration. So pH ranges there. We are having a scale with us, uh, ranging from 0 to 14. 0 means highly acidic and 14 means basic substances, and 7 is relatively neutral, that is distilled water. Now, change in just one unit of scale is equals to 10-fold change in hydrogen ion concentration. If concentration of H plus and OH minus are equal, this is called a neutral solution. Then ions and acids. An acid is any ionic compound that releases hydrogen ions in solution. We have read already. Now, weak acids have a sour taste, like vinegar, acetic acid, and strong acids are highly corrosive, so don't go around the taste testing acids. Examples: ascorbic acid, that is vitamin C, citric acid, weak organic acid in citrus fruits, and phosphoric acid. This stuff is also used to remove rust. Now, strong acids completely dissociate in water. If it dissolve HCl, then it will completely dissociated into H plus and Cl minus ions. And weak acids do not completely dissociate in water. That is acetic acid. It will show only partial ionization. Okay. Now, the base is an ionic compound that releases hydroxyl ions, OH minus ions, in solution. Bases are also called alkaline substances, and some general properties of bases include they taste bitter, okay, opposed to the sour taste of acids, and sweetness of aldehydes and ketones. Touch, slimy or soapy feel of on fingers. And reactivity, strong bases are caustic on organic matter and react violently with acidic substances. Examples are sodium hydroxide, caustic soda, also called, in oven cleaners, and magnesium hydroxide, also known as milk of magnesia. This is a weak base used in antacids and laxatives. Now, ions and salts, compounds that dissociate in water and produce cations other than H plus and anions other than OH minus are called salts. The most familiar salt is sodium chloride, the principal component of common table salt, and other examples are baking soda and Epsom salts. Now, salts, the role of buffers. Certain salts called buffers can combine with excess hydrogen or hydroxyl ions, produce substances less acidic or alkaline. Examples: antacids like Tums are buffers made up of salt calcium carbonate. These are buffers. Reactions involving ions. Remember, ion is equals to an atom which has lost or gained one or more electrons, so it's negatively or positively charged. The principle of ion exchange is a common water softening method. Let's use Bragg analogy to help us understand the concept of ion exchange. Suppose Brad Pitt is negatively charged ion, Jennifer Aniston is a positively charged sodium ion, and Angelina Jolie is a positively charged calcium ion. Now, the calcium ion is more positively charged and sodium ion is less positively charged. So, let's say the positiveness equates with gorgeousness. So, If Brad Pitt forms a bond with Jennifer, negatively charged Brad is attached to reasonably positive Jennifer. Okay, and if Brad Pitt is attached to Jennifer, now it is attached to Angelina, then insanely it will form more strong bond because the calcium ion are more positively charged. Okay, now covalent bonds involve sharing of a pair of electrons between two atoms. It is example contains CH4, methane, and H2. You can count carbon has 4 electrons in its outer shell, and it forms bonds with 4 hydrogen atoms and shares one electron from each of them, and it completes its 8 electrons in the outer shell. Similarly, hydrogen also shares 1 electron from carbon, and it also forms 2 electrons in its outer shell. Same the concept is with H2O. Oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer shell, and it contains 2 electrons from hydrogen. It shares 2 electrons and it completes 8. And similarly, H2 H ions, hydrogen ions also shares 1 electrons from oxygen atom, and it completes its 2 electrons in its outer shell. Now, oxidation reduction reactions are also called redox reactions. These are chemical reactions in which electrons are gained or lost or shared, what you have read earlier, and this is comprehensively called redox reactions. Oxidation describes the loss of electrons by a molecule, atom, or ion, and reduction describes the gain of electrons by a molecule, atom, or ion. Suppose a compound A, it is oxidized by losing its electrons, and compound B is reduced because it is accepting electrons. So the compound A, which is oxidized, is also called a reducing agent because it is reducing compound B from which it is forming a bond. And the compound B, which is reduced, is also called oxidizing agent because it oxidizes the substance A. Okay, now oil rig is similar example. You can see this image, oil rig platform in NASA, and oxidation is loss, that means oil, and reduction is gain, that is rig. Now the hydrogen bonds, when an atom of hydrogen is attracted to two atoms instead of one, only one, is called hydrogen bond. Now hydrogen bonds attract molecules to each other but do not technically bond atoms together. Bonding electrons are shared unequally by the hydrogen and oxygen atoms. Negatively charged forms an oxygen, and positive charge forms at hydrogen. When the electron and a covalent bond are not equally shared, the molecule is, you can see this hydrogen bonds, the electrons are not equally shared, it is just attracted towards another atom. Found in water, proteins, and DNA, in which the hydrogen ions are present. Now we'll discuss neutrons in our subsequent chapters. So thank you for watching this lesson.